Okay, here we've got an application of the distance formula in the coordinate plane, and I've picked numbers that are kind of large, maybe a little bit uncomfortable, to illustrate the value of the formula. So remember, we're just going to use a variation on the Pythagorean theorem. This is A, this is B, and the x2 minus x1 is the horizontal difference. y2 minus y1 is the vertical distance. So I'm going to sketch in a right triangle. And at this point, because there's grids, we could just count the length of this, square it, count the length of that, square it, add them together, take the square root, and we would get the distance between the 2 points. But I want to use the formula, so I'm going to add in a point right here. Let me get my color scheme completed. And this point is going to have the same x value as this point up here, and the same y value of this point down here every time. So that's 32, 13. And now we just go to the formula and plug it in. Our x2 minus x1. You know what, this point down here might not even be completely necessary. Let's just go straight to the formula. x2 is 48 minus x1 is 32. So the distance will equal the square root of 48 minus 32 squared plus y2 minus y1. Well, here's y2, here's y1. So let's plug that in, y2 minus y1. And we'll square that as well. And don't worry about the fact that this quantity is -4. When you square it, the negative sign is going to go away. And this one here is positive. So 48 minus 32 is 16. So the distance is going to be equal to the square root of 16 squared plus 13 minus 17 is -4, -4 squared. Now we just do the squaring and then the square root. So PEMDAS and order of operations is really important here. 16 squared is 256, and -4 squared is positive 16. So the distance is equal to the square root of 256 plus 16. Mental math should carry us to, let's see, 262 to 72. So the distance is going to be the square root of 272. And in a different video, I will break down how to properly simplify that expression.